Let's go through the Unit 1 mid-unit quiz review. Question 1. AB is equal to CD. I'm going to mark that. There's segment AB, there's segment CD. What other segment is congruent to AB? The answer is AE. And the reason is AB and AE are radii of the same circle, of circle A. Name a segment that is not equal in length to AE. So I would say AF is not equal to AE, and I would say it's shorter and the reason I know that is because AF lies inside the circle. Or circle A. All right, let's move on to question 3. What construction is shown here? Mark and name all pairs of equal segments. So this is a construction of a perpendicular bisector of segment GH. So when we have a perpendicular bisector of GH, K is a midpoint. GK is going to be equal to KH. We also know that this is a right angle. It's also true in this case that IK is congruent to KJ. There's symmetry here. So I marked and named the equal segments. I marked the right angles. I could write GK equals KH, and I could write that IK is equal to KJ. Okay, name the circles in the figure above. I'm at number 4. So this is circle G. I name the circle by its center. So circle G, and the other circle is circle H. Compare the sizes of the circles. The sizes of the circles are equal. And I know they're equal because they share a radius. They share GH. Question 5. Name the construction shown below. Name the bisected angle. So this is a construction of an angle bisector. And a bisector is something that cuts another thing in half. The angle that's being bisected is this angle I'm drawing in purple. And I could name that angle BAC or angle CAB. So the bisected angle is angle BAC. The angle bisector, the line or segment or ray that cuts the angle in half, is this here. It's AD. It looks like it's a line. It goes on forever. I could indicate it going on like that. Number 6, name the transformation shown in each figure. So we have been talking about translations or slides, reflections, and rotations. This first picture is a translation. We are sliding the object. It didn't work. Let me try it again. Sliding the object along the vector shown there. That's a translation. The next one is a reflection. In a reflection, we have a reflecting line that is a perpendicular bisector. So that line that I just highlighted in blue is actually the perpendicular bisector of the segment joining corresponding points. And The third one is a rotation. If I start with figure BDC, oops, like that, and then in Notability, this is kind of a cool feature. If I duplicate it, oops, let me try that again. I copy it, and if I paste it, oh shoot. I'm gonna try that one more time. I'm gonna try it with a different kind of drawing. I'll fill it in here. Okay, so I'm gonna take that shape. I'm going to copy it. I'm gonna paste it. Oh, there we go. So, ooh, I didn't mean to do that. So here I can rotate that figure, and I see that the figures line up. So that's a rotation. Sorry, that was kind of a long way to tell you that that is a rotation. What's the definition of congruence? Well, there's two ways to figure out if things are congruent. Things that are congruent have the same size, the same shape. Another feature of congruence, though, is that when we have these rigid transformations that we just looked at, a translation, a reflection, or a rotation, those things map congruent figures to each other. So rigid transformations produce congruent figures. All right, number 8. Name the steps to create a perpendicular bisector of a segment. I'm going to do it while I explain the steps. So we're going to start with our segment, and we'll call our segment AB. So the first step is to create a circle. Create circle B with radius AB. Okay, then I don't know if this is how well this is going to work. What I'd like to do is copy this circle, just the circle. Because what I would like to do, it got too small, it needs to be the same size. What I'd like to do is to create circle, this isn't working. What I'd like to do is to create circle A with the same radius. So I would create a circle that goes like this. Just a reminder, when I say circle A, I mean the center is at A. Now the perpendicular bisector is the line through the intersections of the circles. So, switch colors here, I'll go to green. So this point up here is an intersection, this point here is an intersection, and if I draw a line through those intersections, I get my perpendicular bisector. Remember, perpendicular bisector means it cuts the segment in half and it's perpendicular to the segment. Okay, number 9, reflect the points over the line. So a couple of things I want to point out here. Points A and B are on the line, and when we reflect them, they stay where they are. Let's look at point D. When I reflect point D, what I'm thinking about is that if I join D and its reflected image, which is called D prime, the reflecting line is a perpendicular bisector. Let's do it for C as well. So when I place C, I want to create a point, C prime, such that this reflecting line is the perpendicular bisector of the segment that I just created between C and C prime. If you have a mirror handy, this is check it out with a mirror. We practiced that in class. Okay, number 10. Translate segment AB by the vector. What information is needed to perform a translation? Okay, so to perform a translation, we need a pre-image, which is our original object, and we need a vector. The vector tells us how far and in what direction. So if I take this vector and copy it and paste it, this tells me that I'm going to move point A, which is right here, I'm going to move it here to A prime. And then I'll paste the image again. So that tells me that point B is going to go here to B prime. And then the segment would be the segment joining those two. So my answer is this. I just circled in green. Are the image and the pre-image parallel? Yes, they are. They're parallel. In other words, this line didn't turn at all. It's still got the same orientation. So yes, they are parallel. All right, let's look at this. Describe the transformations needed to take A, B, C, D, E, F to A double prime, B double prime, C double prime, etc. So we actually have two things here. The first one is actually a rotation. Here, A is rotating to A prime. Let's see. B is rotating to B prime. These triangles are equilateral triangles, 60 degrees and 60 degrees. So first, we're going to rotate clockwise 120 degrees. Then this next thing from the shape I just made to the next shape is a reflection. So we're going to reflect over line, I'll call it E double prime, C double prime. I'm going to reflect over that line. One more, I think. Yep, one more. Describe transformations that take AB to FG. So here's AB, here's FG. The lines are parallel. All we've done here is gone 1, 2, 3, 4, 5 units to the right. So I would say this is a translation or a slide, 5 units right. Next one, take AB to ED. AB to ED is a rotation. This is actually rotated around point C, 90 degrees. And it's counterclockwise. So counterclockwise is that way. By the way, clockwise goes the same way a clock's hands goes, like the clocks in the classroom. Clockwise is that way to the right. Let's see, rotate counterclockwise, 90 degrees. Let's look at taking AB to HI. This one's kind of cool. We're going to reflect it over this line. Look at this. There's our perpendicular bisector. B and H go together, and A and I go together. So reflect over the dotted line. Okay, I hope that was helpful. If you have questions, I'll see you in class.